When working with limits, we run into a couple of limits that cause us some difficulty. And these are special limits because they deal with trigonometry. So our first special limit that we want to look at here is the limit as theta goes to 0 of sine of theta over theta. So we're going to use this unit circle here to help us investigate. All right. So we've got an angle, and we can change this, and we want to see what happens when that angle theta goes to 0. So as theta goes to 0, well, remember the sine of 0 is 0. So the sine of theta is also going to 0, and so we end up with 0 over 0. Well, what is 0 over 0? Is 0 over 0 1? Nope. Is it 0? Well, we can't actually figure it out because we can't divide by 0. All right. Well, so there's a limit that we can't quite figure out. Another limit that we can't quite figure out easily is the limit as theta goes to 0 of 1 minus cosine theta over theta. So as the angle shrinks, as theta goes to 0, well, remember the cosine of 0 is 1. So this is 1 minus 1. So watching the numbers there, all right, it's going to 0 over 0 also. So what is 0 over 0? Well, it's undefined. We can't figure that out. So we have two limits here that we can't figure out by just evaluating them. And it can't really be simplified either. So let's think about this picture a little bit. We've got to look at it a different way. We've got to use some geometry here. So we got a circle, and what's the radius? Well, it's a unit circle, so it's obviously 1. So we got 1 there, and we also have 1 there. So those radiuses are 1. Keep that in mind. All right. How do we measure angles in the unit circle? Well, this is the central angle here. And we want to measure that in radians, not degrees. The reason why we want to measure that in radians is because the definition of the radian measure is the length of this arc right here. This arc that is intercepted by this central angle. So this arc is right now 0.8331. And the measure of this angle in radian measure is 0.8331 in radians. So radians tends to be useful because it's an actual length, not just an arbitrary number. Well, let's think about the sides of this triangle here. We've got a right triangle, and we want to figure out the lengths of these sides. Well, how do you figure the length of this? This is opposite of the angle, and we know opposite over hypotenuse is sine, so the length of this vertical leg is the sine. What's the length of this horizontal leg here? Well, that horizontal leg is adjacent to this central angle. We have adjacent, and the hypotenuse of this triangle is 1. Adjacent over hypotenuse is cosine. So the length of this, from this 0 to this point right here, the length of that leg is cosine. Okay? That's why the coordinates of a point on the unit circle is cosine in the x direction and sine of the angle in the y direction. All right, well, let's look at this limit again. Okay? So we have the sine of theta over theta. Okay? Well, what's going on? All right, we know it's going to 0 over 0, but let's look at this picture a little bit here. All right, so sine of theta is this vertical line, and theta is the length of this arc. And so as we shrink this down, all right, I'm going to zoom in. Okay, we're going to shrink it down. So the angle's getting smaller, but I'm zooming in on that picture, and what's happening? This is a circle on the outside, and we've got this vertical line still, okay? But this circle isn't looking very round. In fact, the more we zoom in here, the straighter this circle looks. And this is a good example that when we get down, when we zoom in on any curve, at some point that curve looks like a line. And that's a real important concept in calculus. All right, everything is approximately linear when you zoom down to a finite value. So what's happening? Well, what's the comparison of this orange arc and this green straight line here? Well, they're pretty much the same, right? So as the angle goes to 0, those things are pretty much the same. Since they're pretty much the same, their values are the same, and when we write them as a fraction, that value is 1. And so here we have, notice you can kind of see, well, they're pretty much going to the same. And so what is the limit? The limit is 1. So the closer we get to 0, those are basically the same, and so the limit is 1. All right? Great. Well, what about our other limit? So our other limit here, 1 minus cosine. Well, where is 1 minus cosine? Well, we said that this whole length here is 1 from this horizontal length to the edge of the circle. We know that cosine is the actual length from 0 to this point. So 1 minus cosine is this little leftover piece here. So that's 1 minus cosine, that little red line there. Okay, so we want to compare that little red line to this orange arc here. Okay, so that's what we're comparing. 1 minus cosine over theta. That's our limit. What's the comparison of that little red line and that orange line as the angle goes to 0? All right, well, let's look at it. Angle's shrinking, and it's shrinking. We're comparing this 1 minus cosine is that red line to that orange line. Let's zoom in because it's getting hard to see. Smaller angle, smaller angle. Okay, that little 1 minus cosine is kind of disappearing, right? And this orange line, because I zoomed in, is many times larger than this. The angle, that arc is, it's small, okay? This is a small radian measure. It's going to 0. But what's the comparison? A fraction is a comparison. This is many times larger than that, okay? And so as we shrink down, now I can't even see that little red line. It's there. There it is. See that little red line? It's still there because the angle's not down to 0 yet. But that orange line is thousands of times bigger than that right now. All right? So, okay, so the bottom is a lot, the theta is a lot bigger than 1 minus cosine. So 1 minus cosine is pretty much disappearing. Okay, and so as we go find this, now watch the numbers. 1 minus cosine is becoming very small. That's in scientific notation there, right? So this is a very small number on top over small but not as small. So we've got a tiny, tiny number on top, so that's over something, and so that's going to 0. Okay, so our two limits, we now have proven to ourselves that the limit of sine theta over theta is 1, and the limit of 1 minus cosine theta or theta is 0.